Welcome to the day 14 Night Charge. This is the beginning of the second unit of Math 3. And each one of these is just solving a fairly simple linear equation. This should be review from either Math 1 or Math 2, or even before that, maybe some middle school math, Math 8 or 7th grade math as well. Okay. For each one, the key is to isolate the variable so you can get all the way down to either x equals or a equals or y equals. Okay, so this is what solve means. It's finding the one value of x, a, or y, which would make the both sides be equal. Okay, so one way that you can solve these always is just try to guess and plug some numbers in, see if it works. That's not very mathematical, but it's often somewhat successful. Okay, but even better is to use the rules of algebra to simplify them down. So for example, use the ideas of inverses, things that negate each other, cancel each other out. So addition and subtraction, multiplication, division, or later we'll talk about squaring versus taking the square root. So each one of these are inverses, opposites, and then it will help us cancel some stuff out to solve for the variable itself. Okay, so for this first one, 3x plus 4 equals 5. A lot of times what I recommend is locate the variable, and that right there you want to leave and adjust everything else. So start as far away from it as you can get on the same side. So that would be this plus 4. Subtract 4 from both sides. So you would get 3x equals 1. Okay, do we have x equals yet? No, we don't. So how do we get rid of it? Well, 3x is actually 3 times x. So do the opposite to get rid of the 3. 3 times x, the opposite of 3 times is divided by. So that would be this middle line over here on the right. Opposite of multiply is divide. So divide by whatever is multiplying that x. Okay, and so the 3's cancel out. You get x equals 1/3. Now you could try to reduce that. It doesn't reduce. You could divide it and get the decimal, but that's going to be less exact. So x equals 1/3 is a great final answer for this one. Okay, number 2. Here's your x. This one's going to present something that's a little bit trickier, so it's good to learn it now. So you want to get rid of everything else that's on this side. Now, this one's going to feel a little bit weirder because actually when we solve it, the final answer is going to have x on the right-hand side instead of the left-hand side where you would normally want it. One thing that you can do is just switch the two sides of the equals. So we could say 4 minus 2x equals 5. So all we did is took what was on the right, put it on the left, took what was on the left, put it on the right. It doesn't matter what side it's on. That's how equality works. The left side is always equal to the right side, so you can just switch them. Okay, well, now here's my x. What you can do, again, go away from that minus 2. Don't touch that one yet, and let's get rid of this 4. Now this 4 is a plus 4. Go back to your chart on the right. The opposite of adding is subtracting. So if we subtract 4 from both sides, that'll cancel out, and we'll have negative 2x equals 5 minus 4, which is just 1. Okay, now we're back down to that next step where we want to get rid of the minus 2. Now, don't get distracted by the fact that it's a negative 2. Keep in mind, what is it doing to the x? Well, it is multiplying the x. The opposite of multiplication is division again. Dividing by negative 2. Negative 2's cancel out. X equals 1 over negative 2 or negative 1/2. Again, you could try to reduce it. It won't reduce. You could try to divide it, and it'll give you a decimal. Okay, number 3. It's with a now. No different from what we were doing before. Now, one thing that is different is we have a here, here, and here. The only place where we have numbers by itself, those on the right-hand side. So let's go ahead and simplify both sides first, and then try to get all of the variables on the left-hand side. 3a minus 5a is a negative 2a. Okay, and the right-hand side is negative 4a plus 2. Well, before we do any multiplication or division, we want to go ahead and see if we can get rid of the variable from the right-hand side and get it on the left-hand side instead. So what we're going to do, right now it's a minus 4a. The opposite of a minus 4a is a plus 4a on both sides. So that gives us a 2a equals negative 4 plus 4 cancels, 2. Okay, so now you have a 2a equals 2. Well, now we're back to that middle step. 2 times a, do the opposite, divided by 2, divided by 2. 2's cancel out. We have a equals 2 divided by 2, which is 1. number 4. Okay, look at what we have. So we have a 5 that's outside of parentheses. So that could be multiplication if we want to, or we could maybe try to get rid of it first, equals 5. I only see x's on the left-hand side. I don't see any variables on the right, so looks like we should probably keep our variables on the left and get rid of all the numbers. Well, one thing that you may try to decide to do is to distribute your 5 first to both. That wouldn't be a bad idea. But since right now it's 5 times everything that's in parentheses, it's going to be a little bit easier if you just divide by 5 very first. Okay, so if you thought of doing it a different way, that's totally fine. Dividing this by 5, though, you get 3 minus 2x equals 1. Okay, now this looks a lot more similar to number 2, where you have a number minus 2x. Well, looking back to what we did, you need to get rid of this 3, and it's being added right now. It's a positive 3, so you can do minus 3 to both sides. So you get negative 2x equals negative 2. Now divide both sides by negative 2, and you get x equals negative 2 over negative 2. It's the same number on the top and bottom, so it's just going to be a positive 1. Okay, 2 problems left. Number 5 is going to be something different. So anytime you have a fraction, kind of look around, look at both sides. Where do you see your variable? Well, that y is the only variable that's in this whole problem. So we need to isolate that one. Okay, and so it's going to be a little bit of work to get it by itself. The first thing, though, that you need to learn from this example is that in order to cancel out a denominator, you multiply by that number. Okay, but when you multiply the right side, you also have to multiply the left side. So we're going to have 3 times 2 on the left side is 6. Now on the right hand side, don't distribute this. What's happening is that the denominator and the number cancel out. And so we'll have 6 equals 4y minus 6. Okay, well now it's a lot more similar to 1, 2, some of the other ones as well. Here's the only y value. So get rid of your 6. Right here, by adding, that'll do the opposite. That'll cancel it out. Left side, 6 plus 6, so you have 12 equals 4y. Okay, and now that it's just the letters on one side, numbers on the other, now we can just do multiplication or division to get rid of that 4. Since it's 4 times y, we want to divide both sides by 4, and we get 3 equals y. This is the same thing as saying y equals 3. So remember, based on these equalities, it doesn't matter which way you have it. So 3 equals y is perfectly fine. A lot of times, though, it feels more comfortable to have the letter on the left, so you can just switch those two sides. Okay, number 6, very similar to number 4, with a number hanging out in front of the parentheses. Okay, either you could distribute if you wanted to, so 4 times x, 4 times 6, or just start off dividing both sides by 4. Okay, the 4's will cancel. You'll get x minus 6 equals 0. Okay, now, fairly simple. Minus 6, you need to get rid of that. Do the opposite, which is plus 6. So x equals 0 plus 6 is 6, and you are done.